we are discussing about the set operations. We have read the set union, set intersection, set difference, and now we read another operation which is very important, is called the Cartesian product of set. We have defined a set as a unordered set of elements, unordered collection of elements. So, if we consider two sets, say A and B, consider two sets A and B having some elements. Now, Cartesian product of A and B are the set of all possible ordered pairs of elements of A and B, is defined as the set of all possible ordered pairs. Set is unordered, but Cartesian product is ordered pairs of elements of A and B. Normally, we denote the product as the A cross B. So, we denote the product, say P equal to A cross B. Take one example. Let the two sets we define like A is 1, 2, 3 elements, and B having 2 elements, say A and B. So, A cross B is the Cartesian product, is the Cartesian product of A and B, and these are set of all possible ordered pairs. So, since A comes first, so it is a ordered pair. So, set of 1A, 1B, then 2A, 2B, okay, take this thing as the simple pair we take. One A, 1B, 2A, 2B, then 3A, 3B. And we can, if I just give a tree type of structure, say I give a tree type of structure. Say A cross B. So, A has 3 elements, say 1, 2, 3, and B has 2 elements, A and B. So, if we see as if this is my A cross B, so we get 1A 1B, this is 1A 1B, 2A 2B, 2A 2B, then 3A 3A 3B. So, we get all possible pairs. So, what is the cardinality of this set? So, cardinality of this set A cross B is cardinality of A into cardinality of B. So, in this case cardinality of A is 3 and cardinality of B is 2. So, this is 6. So, this is equal to cardinality of B cross A. What is B cross A? So, if we see that B cross A, then B has 2 branches, 2 elements. So, 2 branch A and B, and A has 3 elements 1, 2, 3. Since now the ordering is changed, so B cross A is A1. So, if I tell B cross A is A1, A2, A3, then B1, B2, B3, B1, B2, B3. So, clearly the cardinality of A cross B is cardinality of B cross A, but see the A cross B is this set 1A, 1B, 2A, 2B, 3A, 3B, and B cross A is the set A1, A2, A3, B1, B2, B3. So, the A cross B is not equal to B cross A, because the two sets are different, since it is considering a order. So, here elements of A are coming first, and in the pair of B cross A, elements of B are coming first. So, that we can write that A cross B, clearly my A cross B that Cartesian product of A cross B is not equal to B cross A, since it is an ordered pair. Ordering matters here. So, what is our A cross A or B cross B? So, if we consider the Cartesian product of the set itself A cross A is the set 1, 2, 3, the same example if we consider. So, similarly, we can get this is the pair 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. These are the all possible pairs of A's. Similarly, B cross B, the Cartesian product of B only, this is B is AB. So, this is AA, AB, BA and BB. So, again this is one binary operation like set union, set intersection, set difference. So, we have read that 4 binary operations: union, intersection, difference and the Cartesian product on sets. These are the 4 operations, binary operations. Now, we read another very important thing, that a different type of representation or some pictorial view of sets, which we can see as a tool which is very much used or to do some operations on set. So, it is called the Venn diagram. We use the Venn diagram. So, we define Venn diagram as if this is a pictorial view of sets. It is an aid or tool to work on the on sets and the different operations of set. Okay. So, let AB are 2 subsets of the universal set U. Now, we have read binary operations. One unary operation we call the complement of a set is defined as the number of elements is the elements, sorry, not number, this is the that elements defined as the elements which are not present in A. If we consider the complement of A, that means, if I normally we denote this thing as a complement. So, a complement is the set of elements that are not in A, is the set of elements that are not in A. So, that means, if I consider that universal set U and A is the subset of U, so I can tell that this is U minus A. That means, U minus A contains those elements which are not in A. So, we define this unary operation, this is one unary operation, that complement. Now, how we represent the all these sets using Venn diagram. Say we universal set Since it is a pictorial view, so universal set is represented as a rectangle, and the subsets or subsets of universal set, or normally we call the sets, are represented as circles, as circles. So, if A and B are two sets and U is the universal set, then we can represent this thing as, say, this is my universal set U, and this is A, say this is B. So, if I give the notation, this is U, say this circle, the first circle, that is say A, second circle, this is B, these are the sets. Now, I give some region, as if this is one region 1, 2, 3 and region 4. So, what do we mean by this region? So, region 1 contains the elements, okay, I give all the region what they represents. So, region 1 contains the elements that are in the universal set U, but not in A or not in B. So, these are the set of elements. So, region 1 covers the elements neither in A, in set A, or in B. Region 2, region 2 is the elements in A only, but not in B, in A, but not in B. Region 3, that elements that are both in A and B, that are in both A and B. And region 4, like the elements in B, but not in A. So, normally we represent in this way that using the rectangles and using the circles and with these notations that what are the elements we cover. So, see what do we mean by region 2? Region 2 is both are the elements that are in both, or region 3 the elements that are in both A and B, region 3 in both A and B. So, we know that both A and B, that means A intersection B. So, region 2 is actually intersection of A and B. So, elements in A, but not in B, region 2, these we can simply write A minus B set difference. Similarly, region 4, elements in B, but not in A. So, I can tell B minus A. This is the elements neither in A or in B. So, this is, if I consider this is A union B. So, if I consider this is A union B, that means they are either in A or B or both. So, neither, that means it is the complement, that means this is U minus the A union B. So, the pictorial representation, how we define the pictorial representation. The different regions actually represents the different sets or the different operations on the set, like this A union B, A intersection B, set difference of A minus B or B minus A, or this is the complement of the union of two sets. So, normally with this picture we can use in this way. So, if I just see that more on Venn diagram, that examples. So, if I consider simply A union B, simply A union B. As usual, our U is the universal set. We are two sets and U is the universal set. So, we can write this is my universal set, this is A, this is B. So, A union B is this thing. So, this is our A union B. We write this is A, this is B and this is my U. So, the shaded portion is A union B. Similarly, the A intersection C, A intersection B, since both in A and B. So, this is my intersection B. This Venn diagram is used to solve the problems dealing with sets. The very easy way we can solve the problems using Venn diagrams. So, Venn diagram is used to solve the problems with sets or that deals with sets. And we see one example, and then it will be some one class of problems that normally very easy way we can solve using Venn diagram. So, we take one example. We write the problem, say among a group of 165 students, (33 students are taking mathematics and computer science. Twenty students are taking mathematics and physics. And 24 students are taking physics and computer science. Eight students are taking all three subjects, okay, physics, mathematics and computer science. Then 79 students are taking only mathematics, are taking mathematics. If I consider separately, 83 students are taking physics, and 63 students are taking computer science. The question is that how many students are taking none of the subjects, none of these 3 subjects among these 165 students. So, this is clearly a problem of set union, intersection, set difference using mainly these 3 operations. But since already we have seen that how using Venn diagram we can represent the set difference, union, intersection. So, we try to solve using Venn diagram, and that is a very easy way that we can solve this problem. So, for this problem, if I draw the Venn diagram first. For this problem, we draw the Venn diagram. So, this is my universal set, that U is 165 students. Now, here I have 3 sets. One is my mathematics, one is my physics, and physics is 83 students. So, slightly bigger set. Another is that of my computer science. This is my computer science. So, this is my, I represent M, the mathematics, the set of students who are taking mathematics, set of students who are taking physics, set of students who are taking computer science by C. So, let M is the set of students taking mathematics. C is the set of students taking computer science. P is the student, set of students taking physics. Now, we have seen that 8 students take the all 3. So, if I just draw this thing, so this should be 8. So, here it will be 8. Now, if we consider the 20 students or 33 students are taking 33 students are taking maths and mathematics and computer science. So, this is my mathematics, computer science and physics. So, we take that this is my 25 plus 8, together they are taking. Similarly, my 24 students are taking, here 24 students are taking physics and computer science. So, these will be my (16) and similarly 20 students are taking maths and physics. So, this will be 12. Now, I have mathematics students are 79, physics students are 83 and computer science students are 63. So, clearly that I can write these only mathematics students are taking only mathematics student here, that will be 79 minus these 3 we have to cut, that means 12 plus 8 plus 25 difference we take, and this will be clearly 34. So, I can write here it is 34. Similarly, if I take only physics student and only computer science student, we can write 12 plus 8 plus 16 is equal to 47 students. So, only physics students are taking 47 and here I can take 25 plus 8 plus 16 is 63 minus 49 is 14 students are taking only computer science. Now, we get that all union of the set of mathematics, physics and computer science students that are together, if I take, it will be 156 students. And since our universal set, that means all students will be 165 students. So, the students who are not taking any of the subjects, that is clearly that U minus that union of this, that means 165 minus 156 and this is equal to the only 9 students. So, we get this is my result, that 9 students are not taking none of the subjects, not taking any of the subjects. So, this is a very common tool of solving problems using set, using the Venn diagram, mainly the set operations.